access points, wireless LAN controllers, and beyond. Let's begin. I'd like you to imagine that you and I are going to implement a wireless local area network, and we're going to do it for an office building that has like 14 different floors, and we'll need several access points on every single one of those floors. Now, just the thought of manually configuring each of those access points for the correct frequency, the correct amount of power, the SSIDs, the encryption to use, and everything else is daunting. So to help solve that, what we can use is a centralized management approach. And to do that, we're going to use a wireless LAN controller. So let's take a look at our components here. We have users or workstations, wireless devices. We have access points. We have a wireless LAN controller. And then we also have some upper level management software to help keep track of it all. So let's consider an access point all by itself. How hard is it to be an access point? Well, it's a lot of work. For example, you've got clients who want to associate with you. If there's authentication configured, you got to do that all on your own. You got to make these decisions. Do I let them authenticate? Do I not let them authenticate, etc.? And then once they're connected, if we have packets and so forth that are being forwarded, we have to convert those. For example, if we're going over to a server right here, and these are 802.11 frames, and over here we have 802.3 with Ethernet. The AP has to do all that manipulation of the frame format from one to the other and then back. It's a lot of work. When we bring in this wireless controller, a lot of the rules change. We're going to use something called split MAC. And here's how it works. For the access point, the controller says to the access point, listen, you want to work with me as a dynamic duo, and I'll take some of the heavy lifting off your shoulders. And the access point says, what? What do you mean? And the controller says, well, I'll tell you what, when people want to authenticate, you no longer have to make that decision. I'll make it. Just forward the traffic to me, and I'll make that decision. The access point says, fantastic. The controller also says things like moving packets and reformatting the frames and all that good stuff. I'll take care of that as well too, so you don't have to do that heavy lifting either. So now the access point gets a little worried and says, well, what do I have to do? And the controller says, well, you need to run your radio and actually process the signals that are being sent back and forth. Also, if you get a frame of data, go ahead and send that acknowledgement that's so important in 802.11. So any type of real-time, immediate traffic, you're going to go ahead and take care of. But as far as making decisions about authentication or authorization, I'll go ahead and do all of that work. So over here at the AP, he would still be doing his beacons to let everybody know there's a wireless network in place, advertising the SSID. It would also respond to probes. So if there's a client saying, hey, is this service set ID available or out there? He would respond to that probe. So any kind of real-time traffic would be done here. Additional things would be the things like RTS, CTS, if it's being used, and any real-time 802.11 related traffic. And over here at the controller, he can handle the authentication, the authorization, disassociation requests. Any kind of policy will be implemented right here at the controller. In addition, if this controller is managing lots of different access points, guess what? It can now coordinate the radio frequency channels that each of them are using. So if we laid out, for example, 6 access points like this, again, this is the top view, controller would know exactly how strong those signals are because it has feedback from the access points. So this access point, just to be clear, says, okay, Mr. Controller, you're saying that I'm in charge of beacons, acknowledgements, RTS, CTS, real-time traffic, and you'll do most of the other stuff as far as decision-making, authorization, association, etc. The wireless LAN controller says yes, and then the AP says, wait a second, stop the truck. How in the world are you going to know? For example, let's say Bob right here is trying to associate with the access point, wants to do authorization and get access to the network. How in the world is this wireless LAN controller, which could be on the same network or it could be several networks away, how is this wireless controller going to know about that? And here's what they're going to do. They're going to use this protocol called CAP-WAP. I kid you not. It's fun to say, no doubt. And it stands for Control and Provisioning of Wireless Access Points. Control and provisioning of wireless access points. You may want to jot that down to help remember the acronym. It's the language of love between an access point and its controller. So the connectivity would look something like this. And we're really going to have 2 different streams. One's going to be control traffic, and the other is going to be for data traffic. So for example, if the wireless LAN controller decided it wanted to put this access point on a different frequency or a different channel, it would use the control channel to communicate that with the access point. On the other hand, if Bob actually wanted to send traffic through the network, assuming he's associated and authenticated, when Bob sends his data traffic, the access point, and this is where it comes into traffic flow, the access point is going to take Bob's traffic, which I'll put in pink here, and it's going to encapsulate it inside of CapWAP and forward it down to, over the data connection, over to the wireless LAN controller. It's up to the wireless LAN controller to then go ahead and decide how to forward that. So for example, if there's a server sitting right here, that frame, which over here was 802.11, coming in, that frame is now encapsulated inside of CapWAP as it's sent to the wireless LAN controller. The wireless LAN controller de-encapsulates that. Now it's looking at the raw 802.11 detail. And then if it's going to forward out one of its ports towards a server on Ethernet, it would then convert the frame with the appropriate layer 2 source address, which would be Bob, the client, and the server, if it's on that same VLAN, or the destination layer 2 address would be the appropriate router that would then take the packet to forward it to its final destination. So we can kind of think of this progression as there's always a bigger fish. For example, these computers right here, could they do networking on their own? The answer is yes. They could use ad hoc. No problem. That would work for simple sharing of files and things back and forth. However, if they want to connect to a distribution system, they need to go and move to infrastructure mode. And they can do that with a standalone access point. You don't need to have a controller, a single access point, not a problem. It has the distribution system out to the rest of the world, usually through a wired connection. Now, as we progress and we have multiple access points that we need to configure to save energy and time and coordination, we can do the split MAC and have our wireless LAN controller manage these devices. And then literally, after we do our site survey and identify where we need to put the access points, once we put them in, the wireless LAN controller can be responsible for monitoring those devices, changing the power levels. For example, let's say we have several access points here. We'll go for 9. And let's say that we have a failure. One fails. So that wireless LAN controller, now knowing that that access point is no longer responding and working with him, he can go ahead and increase the signals on this guy and perhaps this guy to cover that area, assuming they weren't at 100% already. So the controller can intelligently, and most of the time transparently, make those types of decisions, which ends up in having happier users because they aren't having downtime. The wireless network didn't just quote unquote go away or die. So now you and I get to manage a wireless LAN controller, which is then in charge of the access points. All right, little pop quiz for you. Which device would be responsible for authentication of a user in a standalone or autonomous wireless local area network? What I'd love for you to do is go ahead and pause the screen, decide on what you think the best answer is, and then resume it. We'll take a look at them together. Now this question is a little bit tricky, and that's because in our discussion we said this wireless LAN controller, this guy right here, he now with the split MAC has the responsibility, or can have the responsibility, of doing the authentication and authorization of individuals. However, in the question it says standalone or autonomous wireless local area network, which implies there is no controller involved. And as a result, it's the access point on its own power that's going to be making those decisions regarding the authentication of a user. It doesn't have, in a standalone environment, it doesn't have a wireless LAN controller to go to. In this video, we've taken a look at the split MAC and some of the responsibilities between the AP, that's doing the real-time 802.11 stuff, and the wireless LAN controller that's now responsible for things like authentication and authorization and policy. So if we want to change the policy and push it out, we'd make the changes on this wireless LAN controller, and it would go ahead and push those changes out to the access points that were managed by that controller. We also took a look at the language of love, CapWAP, that is used to communicate between an access point and a controller. There's two logical channels. There's a data channel and a control channel. I've had a great time. I'm glad you joined me. I hope this has been informative for you, and I'd like to thank you for viewing.